This is a non-public demonstration of ChildScene, a system designed to process images of child abuse, often from seized hard drives, by comparing the images, even if heavily cropped, against a database of known scenes. It builds on our earlier experience in developing the child-based system for the UK National Crime Squad. This was launched at the House of Lords in London and was the largest system of its kind in the world at the time. While hashing techniques can be used to match exactly the same pixel pattern, they don't work if an image has been cropped, reformatted, resaved, etc. ChildScene goes far beyond any existing means of addressing this. With scenes of abuse as the core entity, ChildScene links victims, offenders, their scars, marks and tattoos, and specific objects so that recognizing any of them can lead back to the offender and, if possible, identify the victim. Let's look at it in operation. This is the main screen where scene searches take place. The tabs across the top offer the ability to search databases of scenes, offenders, their tattoos, victims, and objects. To be searched, the distinguishing features of each scene have to be determined and transformed into a unique encode array. Because all the arrays are held in memory rather than on disk, searches are extremely fast. Images to be searched are dropped into the blue area on the right, while top matches are displayed in the black area on the left. We'll start by dropping in a moderately cropped image of a scene. Because a scene can be of anything, on this single PC it can take time to find differentiating features and encode them. However, it's now encoded, and if we click the recognition button, the top matches will be displayed on the left. The top two are of course of the same scene, with the top one coming in at 100% because it actually is a larger version of that scene, and all the distinguishing features from this probe image on the right are present in that scene on the left. Now we'll take a more challenging image. This is a heavily cropped scene, broadly speaking, from this area in the corner here. If we drop it in, once again we'll let it encode, and then when we hit match, one of these scenes comes up, the larger one, to indicate that it is the top scene, and that's the correct match. In this example, the probe shot is taken from one side of the room, while the database shot is from the other. Just drop it in. For good measure, the database image is a JPEG and the probe is a PNG, so they're also very different compression formats. Once again, if we click recognition, the correct scene from a very different angle will appear as the top match. If the object's really small, we can switch to a more detailed recognition process, so we can link scenes together by recognizing a common object in them. ChildScene includes the ability to filter searches by dominant color or by text descriptors. By these means, ChildScene can link instances of the same location being used to abuse different children, likely by the same person. The system includes highly advanced face recognition technology and has the unique ability to work with just part of a face. To demonstrate this, I'm going to go to the offender database, and in particular the offender search screen. Now, because it's a partial image, we're going to select partial mode, which displays a standard facial template onto which we can drop the face part. Now, as you'll see, it's a different size to the template, and we can use the scroll wheel on the mouse to enlarge that until it's, bring it down just a little bit maybe, until we've got as good a match as possible. We can adjust the size of the nose up and down, and we can also move the eyes in and out. When we're as comfortable with it as we can be, we can then set the eye centers manually. And having done so, we can click the recognition button, and Juan Perez correctly comes up as the match. Some images may include part of an offender's tattoo. ChildScene can find these in the database and display the name of the owner. To do this, I'll go to the tattoo side of the system, and we'll drop in a full tattoo in this particular instance. Once again, it has to be encoded. And if we click the recognition button, then Dwayne Berlitz comes up as the #1 match, and as you can see, it is exactly the same tattoo. Let's show you something slightly more demanding. If we take a small crop of that tattoo, just the claws at the right hand end of it, and click the recognition button, once again he comes up with the correct tattoo as the top, and in fact only match. A seized hard drive can be connected to Child Scene and all the images automatically compared against the central database of known scenes, so new images can be readily separated from known ones. All previously unseen images can have a severity rating added and then be added to the central image database. In addition to still images, Child Scene can work with images in video files and websites, as well as different databases on a secure network. To speed up the overall process, hashing techniques can be used first to remove system images, etc. So that's a brief introduction to Child Scene, a major leap forward in distinguishing known from previously unseen images, recognizing child abusers, hopefully recovering children, and dramatically reducing the trauma experienced by officers who have to deal with those images. Thank you.